All right, let's pick up where we left off, talking about average rate of change. So again, if you need to pause the video to get the definition written down, you may. I'm going to take a second and sort of dissect this definition, and hopefully you'll be able to see that this is something you already know. So average rate of change, the ratio between the change of the dependent variable to the change in the independent variable between 2 points. Okay, that's a lot of math talk. Let's break it down. So ratio, we're talking about a fraction. Okay, so a ratio is a comparison of two things using division, so you set it up like a fraction. Okay, the dependent variable, that's your y values. And if we're looking at change in the dependent variable, that's telling me that I'm going to subtract. Okay? And so this is where we start, is we subtract the y values, and then we compare it, or we set it up in a fraction, with the change, which again is going to be subtraction of the independent variables, which are your x values. Okay, so now that we've kind of broken that down, let's look at what average rate of change looks like. By the way, I use this abbreviation a lot, AROC. Average rate of change is the difference in the y values. So if I have two y values, I'm going to take the second one and subtract the first one. And then I'm going to make a ratio with the x values, the change in the x values. And hey, that should look familiar to you. I hope that your brain is screaming at you, wait a second, that's just slope. And that's absolutely right. Slope is a measure of the average rate of change between 2 points. That's all it is. So when we talk about average rate of change, you're using the slope calculation. Okay? And then as we do some of these problems, we'll talk about interpreting it and what is this really saying. But essentially, it's giving you the average, right? This is an average rate of change. The average amount that the y values are changing for every one step that you take along the x-axis. Okay? So I've got an example down here. There's two different functions here, this one and this one, and they both want you to find AROC, average rate of change, between 1 and 4. Okay, so here's x equals 1, here's x equals 4. Okay, and what we are going to do is subtract the y values and subtract the x values. So I'm going to do this as my point number, this is my point number 1, and this is my point number 2. Okay, so when I say y2, that's the y coordinate from point number 2. It actually wouldn't matter if you switched those around as long as you kept it consistent between the x's and the y's. So I'm going to say 27 minus 12 over 4 minus 1. y2 minus y1, x2 minus x1. Sorry, I didn't realize how low that was on the screen. All right, so 27 minus 12 is 15. 4 minus 1 is 3. And then 15 over 3 is just 5. So what that means is if I were to look at these points on a graph, and I was trying to climb from this point up to this point, on average, I would have to go up 5 y values for every step I took along the y-axis, or I'm sorry, along the x-axis. Now, is that actually happening? Well, if I jump from 12 to 16, I'm only stepping up by 4. And 16 to 22, I'm stepping up by 6. And then 22 to 27, I'm stepping up by 5. But if I were to average all of those steps together, it's an average of 5. So this word average is important because it's not saying that I'm literally climbing by 5 every single time, but on average, that's what I'm doing for every step that I take. Okay. Now, if it did happen to work out where I was climbing by exactly 5 every single time, that's a special type of function, and we're going to learn about that in the next lesson. Okay, so this next one is given to me as an equation rather than in a table, and so I have to do a little bit of work. I know my x values, but I need the y values that go with them. So I know it's 1 comma something and 4 comma something. But I'm going to have to use the equation to get what those y values should be. So if I plug 1 in here, 1 squared is 1 plus 3 is 4. And then if I plug 4 in here, 4 squared is 16 plus 3 is 19. And then I'm going to do y2 minus y1. So again, this is going to be my 0.1, this is going to be my 0.2. And so I'm going to go 19 minus 4, because that's 19 minus 4, over 4 minus 1. I feel like this is magical. I don't think I meant for this to work out quite so nice. But 19 minus 4 is 15, and 4 minus 1 is 3. And once again, we have an average rate of change of 5. I don't think I meant for those to be the same, but that's okay. This is still the average rate of change. Now, does that literally mean that every time I step 1 along the x-axis, my y value is increasing by exactly 5? It does not, but it's an average over that interval between 1 and 4. Okay? Okay, moving on. I think we've got one more set of things to talk about. Oh, and you've seen this before. So I'm going to go really quickly through this. Vertical line test. So remember we talked about functions are one input to one output. That's a really important aspect of what functions are. If you're looking at a graph, the vertical line test is how you can quickly do a visual check for that relationship. Okay? So if you look at this first graph right here, I can draw a vertical line anywhere on this graph, and I'm only hitting one y value each time. I'm only hitting the graph one time, okay, for every x value that I choose. What that's telling me is that whatever x value I'm choosing along the x-axis, it's only got one place to go on this function, okay? So this one would be a function. However, this one over here, if I draw a vertical line, let's just say right here, I hit the graph twice, and what that's telling me is that this one x value, this -2, has two partners, right? And that's not okay in function land. So this is not a function. So just a quick reminder there on how the vertical line test works. And then let's cover function notation. Now, I talked a little bit about function notation earlier in this lesson, so this should go pretty quickly. But when you see this, this is not multiplication. This is read as f of x. That's how we say this. And literally what that's abbreviating is function of x. So function of x equals, and then you would have some relationship after that, okay? So when I put a number in there, when I say f of 5, that's telling you, first of all, that the x value is 5, right? Because the x is what goes in the parentheses. And it's saying, give me the y value that is paired with 5 in the function f. So the f is really like the name of the function, and so you can have equations that have multiple functions in them. Sometimes they'll use letters other than f. But f is just telling you which function am I looking at, which relationship. And if I ask you for f of 5, I'm saying what y value is matched up with 5. I'm asking you this question. 5 comma what? Okay? That's the answer to f of 5, is what number goes right there. So let's practice that just a little bit. One more example to get through here. So you've got a function and its name is h. Okay, so the h of x function is x squared minus 1 over x. That's defining how your relation is being formed. How are you pairing up these numbers? And so when I say h of -2, I'm saying find me the y value that goes along with -2 as an x value. So what I'm doing here is I'm plugging that -2 in place of the x. Trying to go without a calculator as much as I can here. Well, -2 squared, by the way, if you are typing this into a calculator, those parentheses are going to be important. Anytime you square a negative number, it has to be in parentheses, because we are smart enough to know that -2 squared should be +4. And then I have a minus negative 1/2, so I'm really saying 4 plus 1/2. And so I'm just going to say this is 4.5. So in this function, the coordinate would be negative 2 comma 4.5, one of the coordinates. Sometimes I make you plug in really weird things. Sometimes I make you plug in things like 4m, right? So that just means replace the x with a 4m. And there's not a whole lot of simplifying we can do here. We can say 4m squared is like 16 and then m squared. And then minus 1 over 4m. If we wanted to go further with getting these two things combined together, we'd have to do like some common denominators and things like that. We're not really there yet algebraically. This answer is perfectly fine. But I can't solve for m or anything because it's not equal to anything on the other side. So I'm just going to leave this alone. This is my final answer. Now this last example really wants you to think about the difference between these two things. Okay? This problem here is telling you plug in 2 to the h function and then plug in 3 to the h function and take the two answers, so remember these represent the answers or the y values, and add them together. Okay? Before I do that, let's just talk about this, what this one is saying to do. This has the 2 and the 3 added together first. So this is really the same thing as just saying what is h of 5, right? And that's different than what this is going to be. Okay? So h of 2 is 2 squared minus 1 over 2 plus h of 3, which is 3 squared minus 1 over 3. Oh, this is going to get a little messy, but let me simplify it a little bit. So we have 4 and we have 9, right? So I know I have 13 minus 1/2 minus 1/3. Okay. So to add these together, I am going to need a common denominator. Let's not panic at the sight of that. I think we can handle this. 2 and 3 both go into 6, so I'm going to turn everything into something over 6. So 1/3 is really 2 out of 6, and 1/2 is really 3 out of 6. Okay? If that's confusing to you, just think your way through it. What did I have to do to turn a 3 into a 6? Well, I multiplied it by 2, so I multiplied the top by 2. Now, 13, if I want that to be something over 6, this is really like a 1 right now. So I need to multiply the top and the bottom by 6. So let's see, 6 times 13 is 78. And so this would be 78 over 6. So 78 over 6 minus 3 over 6 minus 2 over 6. Now I've got common denominators. Let's see, 78 minus 3 is 75. Minus 2 is 73. So final answer here is 73 over 6. Now, could you make a mixed number? Could you make a decimal? Sure. In algebra land, most of the time we're happy with our answers that just look like that. So don't let that intimidate you, but that is kind of a math skill that does pop up every now and then, and you want to make sure you're comfortable with it. All right, next one shouldn't be so bad. Next one, we're just plugging in a 5. So we get 5 squared minus 1/5. Okay, that's 25 minus 1/5. 1/5 is really 0.2. So, I mean, a couple different ways you could do it, but if I'm just thinking about decimals, I'm just going to say this is 24.8 because I did 25 minus 0.2. Okay, I'm less concerned about the number crunching over here. I'm more concerned that you understand what to do with these things when I present you with an equation. But if you understand how that function notation works, you should be in good shape.